For question number 19, there is a speed time graph which shows an acceleration, a constant speed, and a deceleration or retardation. We need to calculate the retardation during the last 20 seconds of the journey. Last 20 seconds is here. Retardation is gradient of line, which is y step over x step. So the y step here is 30. X step is 60 to 80, which is 20. So we've got 30 divided by 20. So this is the retardation, which is the deceleration, which then comes to 1.5 meters per second square. First part done. Second part, we have to find the total distance traveled in the 80 seconds. This is a trapezium, so half sum of parallel sides times the perpendicular height. 80, and then from 40 to 60 is 20, so I got 80 plus 20, and then divide by 2. You apply the formula for distance, area, and the graph of a trapezium, multiply by the height, and the height is 30. So if you do that, you should be able to get 100 times 3, which is 300. 100 times 30, which is 3,000, divide by 2, 1,500 meters. So that's the distance traveled in the 80 seconds of its journey. We need to sketch the distance time, the distance time graph for 40 less or equal to t less or equal to 60 is a straight line. State the gradient of this line. From 40 to 60 seconds, it was traveling on at a constant speed, okay? So if it's traveling at a constant speed, then its gradient would be, there's no acceleration. So the gradient means acceleration, so no acceleration. And the gradient is basically like this. So from, let's say here, okay, 40 to 60. It's going to go look like this. So the y step is basically, so 40 to 60 is 20 seconds. So in that 20 seconds, it travels a distance of length multiplied by breadth, which is 20 times 30, 600. So we got then 600 over here, meters. That's the distance time graph. And what is the gradient? The gradient is the distance divided by the time. Time and then distance. So distance over time is the gradient here. And distance over time is basically speed. So we got 600 divided by 20, that comes to 30. Which basically corresponds to this speed here, 30. So therefore, the gradient is 30. Here we are, correction for question number 19 from your textbook. Take care.